ended up doing it where I had the players like roll forward and roll back. And then the time it took to do that, I just whenever it came back, I sure did.
Okay.
I spent like 40 minutes figuring how to use some Unity thing to make it.
I see. All right. So let's get rolling. I have added some stuff to mine here to give us some I don't know, movement and monsters and stuff like that. And then we're going to introduce our equivalent of threads today. So just to give you an idea, I got this dude here. What's this? No, it's like I don't know. He's his name's Chomper. I got it from some monster dealy flippy thingy. All right, so then I have, let's go back to our, because we're going to be wanting to debug our fight scene. So I had changed the chance to get into a fight to 0 for me to handle the rotations for that dude. In fact, actually, let me talk about that real quick, since that's the small change I made here. So what I did is we already had our player, right? So we had our player, and I just turned off the mesh renderer for our player. And I added this new dude, Chomper, who's just he was a prefab from a I don't know, some asset store thing, 3D game kit character pack. And yeah, here's Chomper. And he has a prefab, so I just drug that thing in there. He's just a game object with some stuff on him. So that's Chomper. So he has a little animator already built in that just kind of makes him look like he's breathing. But whatever, we're not dealing with animators in here at this point. But in any case, I just dropped him in as a game object. So we have our player and we have Chomper sitting there as game objects. Nothing special there. And I decided, well, you know what? I already have made my player sphere game object. He already handles the moving around and stuff, right? So why don't I just go ahead and teach Chomper how to just follow him wherever he goes? Make sense? So I created this little script called follower, or the follow script. And this is an incredibly complex script. So this is the follow script. All it does is it takes in a public game object for the dude you want to follow. And then on update, he updates his position to the position of the other dude. That's it. Make sense? So this script's whole purpose in life, Chomper's entire brain is just sent to follow the leader. Okay, wherever the white ball goes, he goes. All right. Makes sense how I made him follow. That way I didn't have to go and rewrite the logic to make Chomper move or whatever, since we're already happy with our logic. This isn't necessarily the greatest idea in the world. It's just, it works. So then after I had him following correctly, I just went ahead and hid the old player by turning off his mesh renderer. So now you don't actually see him anymore. All right. So that's the change I made on that first screen. Questions about that? All right. I don't remember when I'm doing the second screen yet. Does my guy move yet? All right. So on the second screen, I have two different dudes here. This other guy's name is he's from the same pack. His name is Spitter. This is Spitter. All right. So again, I did the exact same little trick. Notice that Spitter has the follow script and Chomper has the follow script. And behind the scenes, I have our player just hidden. So there's the mesh renderer for our player, and I have our monster currently hidden. There's the mesh renderer for our monster. All right. So it's those same objects that I was dealing with before that I'm actually going to do some movement for. All right. Makes sense how this little follower script works. All right. So kind of the reason I did it this way is, again, we're trying to solve problems in terms of the tool we have in front of us, right? Okay, what do I want to do? I wanted this game object to follow the other game object so I didn't have to rewrite the logic for driving the thing around. So I created a script to make them follow. Done. All right. So start thinking about in terms of the tool you're doing and solve little tiny problems at a time, not the entire thing, which then will make you spend a lot more time on these things. Make sense? All right. I did, if you go back here to the I think it's in the player controller. I did go ahead. This is on that main scene, and I took in Chomper. So I just called it the player costume. I took in Chomper as a game object so that depending on which direction the player was going, I turned Chomper in the right direction so he was facing the right thing and coming into the room the right direction, that kind of stuff. So you do that using this thing where you update Chomper's transform to look at a certain exit. So I told him just look at a certain door. If he's supposed to look at the north door because he's heading that way, I just told him to look there, and it just makes him look there. Okay. So that's on when it starts because that's when he's coming in from a certain direction. And similarly, when we are updating, if he's going to the north, I have him look towards the north. If he was coming from the north, then I have him look to the south, right? That's the direction he should be facing when he's coming into the room. All right, so that's how I do the making him look in the right direction. You could mess with, I mean, this kind of works since we have a little top-down view thing. But if you have kind of a 3D look for your game or whatever, you can do this thing called lerping, where your guy will kind of rotate over a period of time using these things called Euler angles. That way he doesn't just snap to the left or snap to the right. He'll kind of meander. But whatever. You could have also not used the look at function and just made your guy point in a certain direction. This is unrelated to the assignment, but just threw in some monster-y stuff in there. All right. Otherwise, if you don't do the look at stuff, your guy will just always be facing in his original direction as he's going north, south, east, west, whatever. Probably turn his, so make sure he doesn't have a rigid body. That way he fits through the corridor sideways, gets stuck. I did have a pretty cool effect on this screen here when I was first messing with them going in and out. I had him move forward. I had the monster move forward too far, and he hit the player, and it was like this really cool, like slow-mo explosion because they were bouncing off that side wall there. It was pretty cool, but I took that away. All right. So in any case, I'm doing that same little follow trick here. Just update every frame, update your position to match the position of the other dude. Okay. So I'll go ahead and rehide my monster, and I'll rehide my player. All right, so now let's talk about how do we get these guys to move kind of forward and back. Now, we have one way of doing things, right now we have this function called update that gets called every single frame, right? Okay, so now you can always try to mess around with things inside of update. I think we saw an example a couple weeks ago or whatever, using something called time delta. So time delta is the amount of time that has passed. Delta is change. So time, the amount of time that has passed since the last time you asked what time it was. So you could make little tiny motions through update where he goes moving forward, but it happens so fast, he looks like he's doing that. So you could do that and then make sure he stops moving after some period of time. I saw some people post on like Slack about they were trying to tell the thread to sleep, something like that, and the whole game was kind of pausing, right? So what we want to introduce here is we want to introduce the concept of threads, like we looked at with our in Java when we had our worker bees. Remember those dudes? Okay, so effectively what we want to have happen is we want to have this set of logic start working in the background, doing something not linked to update or anything like that. It's like kind of a one and done type thing. All right. So what I did is inside, I just created a couple of variables inside of master data. I have just a couple of variables about who should be attacking. Okay, whether the player should attack or the monster should attack. I have them both false at once. This is the guy that says, you know, should one of them bounce forward and back? Whose turn is it? So he does this little dance move thing, right? All right. So then inside, I think it's in the referee. Yeah. So inside of referee, I gave myself access to we had this last time, the game objects associated with the monster and the player. And those are the game objects we've now made invisible that the two monster guys follow, right? All right. So right now I have it set where when it starts, I just force player should attack to true to make it so that the player bumps forward, then bumps back. All right. So here is effectively my run method from threads in Java. Okay, remember threads in Java, we extended thread. We added our logic to something called a function called run, because that guy followed an interface called runnable. And then the magic thing we had to do was call the start method of that thread to make it do its thing in the background, having the operating system manage the thready stuff. So we can think of this IEnumerator as effectively that run method. All right. And what does he say to do right now? Well, he starts off by waiting a half a second. And I just created a little delay in there for when I was testing it. All right. Then I kept track of the original position. That way I can go back to it. So I'm leaving the original position, chilling, going back to the original position. Okay. And I set that original position based on who the current attacker is. You'll see that soon. So the original position is the starting position of whichever dude's attacking, either the player or the monster. Then I pick my target position. Target position is going to be relative to the original position. So I'll start off with the original position. I'll add to it a transform to the right times how far I want him to move. So I'm kind of doing this from the monster's perspective initially, because he'll move to the right, the player is going to move to the left, and you'll see how I math this in a minute. All right. Then I take the rigid body of whoever's currently attacking, and I tell it to move to that target position. Rigid bodies have a function to move from one point to another. Then I chill there for a half a second. So this is the wait for some number of seconds, but this is all happening inside of this thread. So it's not impacting the rest of the game. After that half a second, what do? I tell the rigid body of the attacker to go ahead and move back to the original position. So waits a half a second, boom, waits a half a second, back here. All right, that's what this run method does. So then the question is, when does this run method happen? Inside of update, I'm asking the question each time through, should my player be attacking? If it should, the very first thing I'll do is I'll turn his attack to false. That way he doesn't keep bouncing back and forth, you know, because right now if I you know, turn that guy off and I come back here to the dragon, or the dungeon rather. All right, and really what we're actually seeing here is these threads kind of overlapping each other, so it's kind of like sort of kind of not good is what it comes back down to. So as long as I say, look, I want to do this little ninja move where he bounces forward and bounces back one time, so I don't want to get into this if statement again. I set it to false after I make him move once. There's that, and you can make them wait longer, whatever, increase the pause. All right, so if the player should attack, very first thing I'm going to do is I'm going to say the player should not attack again at this point in time. So he only does this once. Then I'll set the current rigid body of the attacker to the player's rigid body. And then the move distance, I'm going to multiply by -1. Because remember up here, our attack move distance went to the right. This will force it to go to the left if it's the player by multiplying it by -1. All right, so I only do that for the player. The monster, I don't do any multiplying by -1 or anything. All right, so we have our attacker's original position. I set this guy as the player's original position, as opposed to if the monster should attack, I set it to the monster's original position. And I set the current rigid body to the monster's rigid body. Okay, so if the monster should be attacking, I set those global variables to the monster stuff. If the player should be attacking, I set those global variables to the player stuff. Inside here, I operate on those global variables depending on who they're connected to, player or monster. Okay, and this is the magic call. This is how you effectively tell a thread to start using these coroutines. You just say start coroutine, and you give it, you give it the name of the enumerator, which is your run method for your thread, and say run this in its own thread. Effectively is what's happening. But remember, this is only going to happen one time because I turn off this after that. Make some sense? Go ahead.
What's the yield? The yield return?
I think that disconnects from the current top level thread and lets this actually no. This interrupts the current thread because we are inside of the current thread. So this interrupts it and then says wait for a half a second. Yeah, the return is the response to the yield. So yield is returning based on some number of seconds. So this pauses until this guy finishes, and this guy finishes once a half a second has gone by. And if I want to make it last longer, I could just switch these to like 1.5 seconds or something like that. Or maybe you make them delay a little bit less. The delay is going to be less of a thing once we actually add the game side of this in. This is just the demoing the ability to make him move, right? So I added that little delay in there. Otherwise, he'll immediately jump to the middle and you won't know that he started off in his original position. So if I take that original delay out, this guy, you're going to see that it's almost like he started at the already indented position. Make sense? So that's why I give myself a little breather once the scene starts before I move him. All right, so at this point, we have no real game logic. This is all just movement. All right, questions about this stuff? I don't care. Yours, does yours, are you happy with what yours currently does? Yeah, I mean, the assignment was open-ended where, you know, you got to do research, to figure out how am I going to make my dude move, right? What I'm doing is I'm connecting two pieces. We learned about threads with Java. Now we've learned about threads, secondary threads inside of Unity, unrelated to that update function. In case you want to have stuff running behind the scenes, you're still going to have the same issue where you don't want to create 4 zillion threads that are all competing with each other and running down the CPU and that kind of stuff. So there is a competition at work there. But for us, we're only ever creating one, and it's kind of a one and done thing until we flip. Well, we're not flipping right now, but we want to have that death match govern this thing. Okay, so what we want to have now is we want to have a situation where we probably just want to have a kind of a back and forth cadence of these guys doing this little dance where, you know, player moves in, comes back, monster moves in, just back and forth, just to kind of get that logic going. All right, so how will we accomplish that? Well, we're going to go into our referee because we decided the referee kind of handles all, you know, he's like the chess player, right? He's moving these pieces around and he's keeping track of who's dying, who's not dying. He has control of the scoreboards, you know, whole thing, right? All right, he's the puppet master. We should have called him puppet master. Would have been better. All right. So, I don't think anything. I think it's part of the normal stuff. All right. So here in start is where we created our death match. So we had just had, this is a local variable called the match. Where's that guy? No, where's that guy? I can't read. My eyes aren't. Oh, there it is. Death match. And I set the match equal to a new death match, passing him. This is my instance of player. This is my instance of monster. And then here are the game objects associated with those two dudes in case I find those handy. Okay. So let's go and look at our death match. I don't think we've written much in there yet, right? Here's death match. All right, so here's death match. So when we create a death match, we're going to know about our couple of inhabitants. This whole dude 1, dude 2 thing is a little bit, I don't know, weird, but effectively we want deathmatch to be somewhat generic, even though we know that players are fighting monsters inside here. We effectively have dude 1 fighting against dude 2, and there's going to be this back and forth movement type thing. All right, so inside of our deathmatch, we just get the stuff set up, and here's where we actually start the fight inside here. All right, so we're going to go back and forth, having our inhabitants try to attack the other one. That's our hit points thingy. All right, but let's go ahead and let's get that back and forth cadence moved into here. So from our referee on start, we're going to go ahead and say this dot the match dot, what I call it, fight. So we'll tell the fight to start. All right. We might decide that we want to put a little delay in here if we wanted to. Otherwise, it'll start like super fast. So I could do something like this. Maybe call this guy delay before fight. And then we tell this guy to just go ahead and maybe just wait a half a second. And then we start the coroutine. And the start coroutine auto allows you to start it multiple times and have it like on its own little track. We won't need that here, but that's the difference there. So start coroutine, and what did I call it? Delay before fight. And this is where we're going to put our match fight thingamabob. Where I am. I said start coroutine. Okay. Oh, hold on. Whoa, let me. Oh, I understand what you're saying. I didn't call my function correctly. All right, I get it. All right, so start coroutine, call this guy. This guy just sits there and takes a beat and then starts the fight. Okay. So maybe that makes sense. That way the fight isn't already half underway by the time we get rolling here. All right, we can do, increase that delay if we decide we want to. All right, so now this move object thing, I'm going to go ahead and we're going to bring this into our death match, because the death match is kind of the thing that's governing these movements, right? And we've given ourselves our various game objects. So I'm going to get that guy out of there. We're going to go ahead and throw it into our death match. We currently don't know about a couple of these variables, so we're going to bring those in. So our attacker positions. This guy also doesn't have a starting transform, so we'll have to keep track of whose turn it is, but we can make some modifications here. So let's start off by giving ourselves these couple of guys. We can also give ourselves the rigid body of the attacker. So really those three variables there we now need inside of deathmatch. All right. So now remember that deathmatch, this guy is not a mono behavior. So he's not attached to a game object. Therefore, he does not have his own transform. All right. So when we decide whose transform we're dealing with here, let's see. We need to do it relative to whoever is the current game object attacking. So that means we need to pay attention to the current attacker. Actually, you know what? We could even start it at a certain position in the room. Be able to get away with it with this transform dot. So what, just transform identity? No, maybe not. All right. So for right now, I'm just going to set it as this dot dude1go dot transform dot right. And then we'll modify it as needed. All right. So we're going to have our target position being whatever the original position of whoever attacking is attacking. We're going to see how to set that later. We're going to move to the right relative to dude one. That's probably not going to stay where we want it. And then we're going to, or that's probably not going to stick forever, but let's just get the stuff going back and forth inside of here. So then we'll do our attack move distance. That's already this guy up here. All right. So this is what happens inside of our move object routine. All right. So now inside the fight, this is where we want to go back and forth, back and forth. Okay. We might end up using a coroutine in this as well to give ourselves a some pauses, but for right now, let's just do our back and forth thing. So I'm going to start off with wild true. Okay, so we're gonna assume that these dudes keep fighting even through death for the moment. Let's keep piling it on. All right. Really, we want to keep going as long as they're both alive, right? That's ultimately what we want to do, but we're not ready to start talking about the hit point side of things yet. All right. So while true, we want to go back and forth between dude one's turn and dude two's turn. What's I doing here? Did I backspace something up there? And we'll say while true, do this stuff. All right. So initially, we're going to say it's dude one's turn for no good reason. Okay. So we're going to say private current attacker. And this guy is going to be a, why don't we do a game object and a inhabitant? So we'll say current attacker is going to be an inhabitant. And then we'll say current attacker go is going to be our game object. All right. So one of them is going to be the game object that's representing that dude. The other one's going to be the instance of inhabitant that's currently the attacker. That way we have the ability. This is kind of MVC at work here, right? That way we have the ability to ask the instance of inhabitant, how much damage can you do? And then we have the ability to tell his game object to go, all right, visually do his ninja move. All right, so we're going to keep track of who the current attacker is. Now, when we first start, when we instantiate deathmatch, we could do a dice roll or something to see who swings first, but we're just going to say dude one swings first for now. So we're going to say this dot current attacker is going to be this dot dude one. This dot current attacker go is equal to this dot dude one go. All right. So inside of our code here, while true, we want to go ahead and we want to set our initial attacker position. So this dot attacker original position is going to be equal to the position of the current attacker, right? So this dot current attacker go, we need the actual game object, and we want to get his transform. Attacker position is a vector 3, so we need his transform dot position. All right. Right now, the very first time through, current attacker go is dude one. His transform position is going to become the attacker original position, which is used by our thread here. All right, what else does this guy need to know about? He needs to get his target position. He figures that out by the dude one transform right. What we're probably going to do here is we're going to switch this to the current attacker. So the original position plus the current attacker's transform to the right times the distance we want him to shift over. All right, then we have the current rigid body of the attacker That's something we have up here. We have not set that yet. So we're gonna say this dot current current rigid body of the attacker is going to be equal to this dot current attacker game object dot get component rigid body. So this is going to be the rigid body associated with whoever's currently attacking. All right. Then what are we going to do? We're going to go ahead and we got all the pieces that we need. Position, original position. That's there. Target position. Okay. So then we're going to go ahead and we're going to set our, well, we're going to call the routine. And what's our execute start coroutine? So we'll say start coroutine, and where does this guy live? I'm guessing it lives inside of mono behavior, which is an unfortunate reality. That's okay. This will actually be easier anyways to do it from the referee side. So what I want to do here is I want to start this coroutine inside of deathmatch. Notice that coroutine is not starting up here. The reason for that is inside of mono behavior. It's mono behavior exists there. But he's not in the list of static stuff. Now, what I could do is I could give myself the instance of mono behavior that comes from our referee to give myself the his mono behaviorness inside of here. So that actually might be fun. Let's do that. So since I need an instance of mono behavior in order to start a coroutine, I need to say, I'll say private mono behavior. We're going to call this guy referee instance. And then when we create our instance of deathmatch, we're going to go ahead and pass this guy that mono behavior. So he's going to take in a mono behavior referee instance. We'll set this dot referee instance equal to referee instance. All right. So now we need to go back into our referee. And when he builds his instance of deathmatch, we need to pass him one more parameter. That is the instance of mono behavior. So I'm about to ask you, how do we pass that? So let's come back over here to our referee. Here's where we're building our deathmatch. It's expecting one more parameter here. What is the instance of mono behavior from referee controller called? Remember that referee controller is a mono behavior. That is this. This is the instance of mono behavior that is passing into our deathmatch. I don't know why we still have random red lines over here, but whatever. So now we're back inside of deathmatch. Now we should be able to say this dot referee instance dot start coroutine move object routine. That makes sense? So since we grew this organically, if I had to do this over again right now, maybe I wouldn't put the stuff inside of our deathmatch object. But we were far enough down the rabbit hole where I said, look, I need to be able to start a coroutine. Who owns coroutine? Well, it's a non-static method that lives inside of mono behavior. How do we call non-static methods? How do we call instance methods? Using an instance of the class in which the method was defined. What class was it defined in? Inside of mono behavior. How do I get an instance of mono behavior? Well, I asked my referee to go ahead and pass himself in as we were building our deathmatch. All right, so we're kind of following the yellow brick road, and this is reading documentation. How many times have you heard me saying how important it is to read documentation? That's the skill, looking at static versus non-static methods. Is this a method? Is it a constructor? Is it a field? How do I call it? You can figure out what it does. That's just like shopping at Home Depot and saying, okay, well, I need a tool that can bang this nail in. Well, is it going to be a wrench, a screwdriver, or a hammer? And you're looking at these different things and deciding which tool is the right tool for the job, but then you got to figure out how to actually use it. That's where this static, non-static stuff comes in. All right, so we'll go ahead and tell our coroutine to go ahead and get the ball rolling. Now, one thing we want to do, though, is since this is inside of a infinite loop, which is going to become a problem in a moment, right? All this is going to be happening too quickly, so we'll have to interject a little bit. We want to go ahead and be able to flip to the other guy, right? Because right now, we're setting the attacker's original position equal to whoever the current attacker is. Similarly, we're getting the current attacker's rigid body. So I want to be able to ask a question in here saying if this dot current attacker go is equal to this dot dude one go, then we'll say this dot current attacker go is equal to this dot dude two go. Else, this dot current attacker go is equal to this dot dude one go. All right, so this little question session here is just asking who just attacked? Send it to the other guy. So we go back and forth, back and forth. All right. We're still safe to start our coroutine after that. Probably doesn't really matter since the coroutine lives in its own thread. So these two things, this is non-blocking code. So we actually could start this coroutine before this guy if we really wanted to, and then flip these things over. I would probably still keep it afterwards, just so we don't have a weird timing issue. I want to make sure that my I flip to the other guy before my coroutine ends, just in case I really minimize the time for delays and stuff inside of my coroutine. All right. So I'll flip it so that the next time up through this while loop, we'll set the attacker to the other guy's position, yada, 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 do its thing, and then, yeah, whatever. All right, we can debug stuff as we get into this. All right, so now our coroutine should be going, and we've already seen this guy move things in a certain direction. We do need to make sure that we're setting it to the negative value like I had it down here. All right, so if it was that was our player attacking, we need to multiply by -1. So actually, I don't know why I don't just start it off at -1, but whatever, for a negative value. This should flip it back and forth, I think. Well, let's just see what this looks like. All right, so this will make the player go this way first. Next time through, it'll flip. This will make the monster go this way and flip, player go this way, so on and so forth, because we just keep multiplying it by -1 to flip it from a positive to a negative number for our move distance. All right. Now, if we were to run this right now, we're going to see that this only, well, actually, it might be kind of interesting to run it, but you're going to have a lot of coroutines overlapping each other, especially since we're currently doing what? We're currently waiting for 1.5 seconds before we bounce back. And I promise you, it takes less than 1.5 seconds to loop through that while loop once. Like a lot less than 1.5 seconds to loop through that while loop once. So we're going to be calling coroutine after coroutine after coroutine, and these guys are going to be like forcing strange movements on it. Probably not what we want. I suppose we can go look at it just for the academics of the fun of it. Oh, hold on. I still have errors in my, I didn't pull all the stuff out of my referee guy yet. So inside of my update here, I no longer have those. We'll mess with our players should attack thing later, because right now it's our match fight that just starts it going and they just start doing their thing. Okay. Don't do it a bunch of times like that. Go ahead. Yeah. Yeah, we did predict that, but yeah, yeah, it's not the smartest thing, right? But bottom line is the reason that's happening is because coroutines are happening in the background. A while loop executes very quickly, many times per second. Yeah, we have thread after thread after thread after thread spinning up and taking a second and a half each, overlapping each other, probably running out of some. Probably Unity uses something called thread pools. So it has a pre-generated number of threads that are already alive so that their game runs quickly rather than having to like create new threads instantaneously. So we ran out of threads and Unity is not thrilled about this, is what it comes down to. All right. I did save beforehand. So what I'll do is I'll go ahead and push this code for now. Remember that the current state of the code is not in a great place. In fact, what we can do just as a, I'll go ahead and just take the while loop aspect of this out. So it'll just do it one time now when we go in there. So I should be able to kill off Unity. And then I'll go ahead and relaunch it. And we're done. I'll just run this real quick and make sure I'm giving you code that doesn't destroy your computer. All right. So one guy moves once now, even though we are totally prepared for the next guy to do his thing. So we're going to have to come up with a way of going back and forth between them. All right. No homework for Wednesday. I will see everybody then. And I'll push this code now so you have the current version of it.
Oh, yeah. See what I know. They're all things that are yellow.
Dun, 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 dun. What?
Paper, I focus more on, in the workplace, being an IT administrator for coder or whatever.
Okay.
Not too much as a student, okay?